Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem which is fractional knapsack. So the problem statement is basically something which will be going to follow the greedy approach. So what we have given is we have given the weight. So let's suppose this is the weight. So this weight, what we have to do is we have given a value and a weight vector. So the value of each item corresponding to its weight are like this. Let's suppose weight is 10, then its value is 60. Weight is 30, then its value is 120. And similarly, if weight is 20, then its value is 100. So what here we have to find is we have to find, so we have this weight. So let's suppose we have some bag like this. So in this bag we can contain maximum 50 kg of items. So what we have to do is we have to here maximize the value of that item. So this is the thing which we have to keep in mind while filling this bag with some weighted values. So all the values should be filled in the form that the most valuable thing should be placed first, and uh, after that the second valuable thing, and so on. So let's suppose you have a diamond of 10 kgs. So let's suppose you have a diamond of 10 kgs, and then a gold of 5 kgs, and then some wood of 100 kgs. So what do? You firstly choose diamond, and then you choose gold, and after that you choose wood, because the value of this should be in a decreasing order, right? So most valuable should be a diamond, and after that there should be a gold, and after that we given priority to the wood. So this is the greedy approach which we are going to follow here. So what we do, we firstly use this. Let's suppose we have this one. So this is basically the value by weight ratio. So it is going to give for each weight unit what is the corresponding value to it. So let's suppose the value is 60 and weight is 10. So value per weight should be 6, and in the same way 4 and 5 for the other one. So what we do, we just make another vector. So let's suppose a 2D vector, so which is a vector which is containing the pair of it. So first one is the value per unit of weight, and then second one is the weight itself. So this is the vector which we are going to form, and then we sort it accordingly. So let's suppose here we have value 6 and weight 10. So we sort it in like by considering our value per weight ratio first. So if there is a pair of elements inside a vector, then we have to decide like if we want to sort it from the first element or from the second element. So here in this case we want to sort it using the first element itself, because this is the value which we are going to consider the most. So firstly 6 and 10 comes, and after that you can see that since its value is 5, so 5 and 20 would be the second element, and then after that 4 and 30. So what we do here, we have taken W, which is representing the current weight, and P is basically the overall value corresponding to that, or the total price of that particular element. So let's suppose we have weight 50. So what we do, we just select this first element, and then what we do, we multiply the value per weight into 10. So we got value for the first item, so we got 60 here, and after that we subtract that weight from our bag, because we are already consider it in our bag, and after that we left with 40. So what we do, we just since each time we check that if our weight is less than this weight or not. So basically our this weight is greater than this weight or not. So if it is greater, then what we do, we just subtract. So 40 minus 20 should be 20 here, and then what we do, we add the value corresponding to this. So you can see that 5 into 20 would be 100. So we uh, consider this. Now in this case you can see that the weight of this 30 is greater than this actual weight, which is the amount of weight left which we can fill in our bag. So what in this case we consider is that we are going to use this weight and then the weight. So basically we cannot add the whole element, that is 30. So what we do, we just add the partial element. So whatever the weight left, we add this and we multiply it with the value per weight. so which is 4 in this case, so we got 80, and at the end we sum up all and we got 240 as our answer. So let's try to code this up. So here you can see that firstly a vector pair of double comma int should be created, and in this D is basically having the uh, ratio of value per weight, and then G is basically the weight of each ARRI element, and we just push back the pair D comma G. So D is value per weight and this is weight, and then we sort. So we are going to sort it according to the first element inside our pairs. So this compare operator is like this. We have two pair A and B as our input, and what we do, we are going to sort it according to this. So if A dot first, or the first according to the first element of the pair, and after that here double P is representing the total price of our uh, whatever the element we have pushed inside our uh, bag, and then int I is basically going from 0 till n is the size of the pair, like this vector v, or also the size of this array. And then what we do, we check that if our weight is greater than this vi dot second element, which is representing the weight, so what we do, we just subtract the weight, and then we add the value corresponding to that weight in our p. Else there may be possibility that now our weight become less than the current weight element of that particular pair. So what we do, we just add, pi dot first, which is basically representing the value per weight, into the weight left only, and after that we just break, and each time we have to just increment our counter I, and at the end we are going to return p. So let's try to submit this out. So yeah, this is the approach to solve the problem fractional knapsack, which is basically using greedy approach. So if you want to assess the code, then you can check the GitHub link given in the description. And before going anywhere, please do like, share and subscribe to this channel.